let me ask you a question. If an AI system recommends a path, executes logic, and that execution results in high-impact system failure or real-world damage, who is technically liable? Is it the engineer who architected the model? The PM who approved deployment? The manager who relied on the telemetry dashboard? Or the organization that claims the outcome was an autonomous decision? Well, here's the technical reality. Agentic systems now operate beyond full human interpretability, yet humans remain legally and professionally accountable for every stochastic outcome. Today, I want to analyze decision ownership in the era of agentic AI. Not through marketing hype, but through the mechanics of system design in high-scale tech organizations. If you're a software engineer, PM, TPM, or engineering leader, the architectural gap is about to become your primary responsibility. If you're new here, my name is Jacob Marcus. I am a finance manager at Meta, where I focus on capital strategy and the governance of large-scale decision systems alongside core engineering teams. Before Meta, I worked on similar systemic challenges at Amazon Web Services, AWS, and at Apple. I'm addressing this today because these questions are no longer theoretical. They're surfacing in postmortems, audit trails, compliance reviews, and executive-level risk discussions. They're also the same friction points I see daily while mentoring tech professionals at Interview Kickstart. To resolve the ownership crisis, we must deconstruct agentic systems into 3 layers. Temporal logic, when is the decision actually compiled? Control plane, who governs autonomy and owns the kill switch? Accountability sink, who bears responsibility when the system fails? Once these layers are explicit, ownership becomes diagnosable and assignable. Before we go deeper into the architecture, here's a quick diagnostic for you as a practitioner. If you were evaluating an agentic AI curriculum in 2026, what would you prioritize? A, a structured study plan. B, hands-on learning. C, being taught by Faang plus engineering leaders. Or D, all of the above. Well, if you chose D, you should join the free Interview Kickstart webinar linked below. Their Applied Agentic AI course is a rigorous 14-week program designed to go deep, but instead of telling you, I'll let a learner's project speak for itself. So check out the video link at the very end. Now let's jump into the layers. The industry often assumes decisions happen at inference time, when a model generates output. But that's actually a misconception. By the time an agent executes, the critical logic is already locked in. The real decision happens at design time. When you define the objective function, when you set constraint boundaries, when you calibrate probability thresholds, and when you accept the failure modes of the architecture. Saying the AI decided isn't a technical explanation. It's an abdication of responsibility. The system is not deciding, it's executing your design. In agentic architectures, control is often dangerously fragmented. Product leaders own intent, what the system optimizes for and why it exists. Engineers own capability, which tools, APIs, and actions the agent can access. Managers own intervention, how quickly humans can override execution. But control is not just about what the system can do, it's about how well we understand what it's doing. That means going beyond performance metrics like accuracy, precision, and recall, and explicitly designing for model interpretability, observability, and decision traceability. Because if you cannot understand how the system reached a decision, you don't actually control it, you're just observing it. If no one clearly owns the stop logic, you haven't built autonomy, you've built liability. When a system causes harm, the industry doesn't blame the model weights, the agent isn't put on a performance plan, the neural network doesn't testify, people do. So executives are the ones that answer regulators. Engineering teams write postmortems. Companies absorb reputational and legal damage. And increasingly, regulators don't ask what the model did, they ask who approved the system. Here's the asymmetry. Decisions are distributed, but professional consequences are concentrated. And that gap is where career risk lives. Now, you might have heard of this term, human in the loop. Human in the loop is often used as a safety blanket, but it only works if 3 technical conditions are met. The human has full observability into agent reasoning. The human has real-time authority to terminate execution. The human is explicitly accountable for the outcome. If the operator can't explain why the system acted, they aren't supervising, they're the accountable party of record. The most valuable engineers and PMs of the next decade won't be those who simply integrate models. They'll be the ones who can architect robust agentic workflows, define decision latency and timing, allocate control layers across the stack, and own system-level outcomes end-to-end. Ownership of AI systems will become a promotion-level competency. AI won't replace your role, but it will dramatically raise the bar for how you reason about system design. If you want to build these systems, not just use them, you need structured exposure to those layers in practice. Everything we've discussed today, from control boundaries to accountability frameworks, is exactly what the applied agentic AI model is designed to address. Come join the free webinar in the link below and meet the team. See if this is a fit for you. If you want to hear from our existing learners' experience and see the projects they've built, check out this video right here. And until next time, bye.